tripod up. Start working on this. Hello, hello, welcome to the channel. Got a lot on the docket today. Well, just a lot of things that I'm working on. I was going to show you the reed switch / trigger strand combo and then how it costs so much less to run and you get maybe even more speed out of it if it's timed correctly. So I made both switches mobile so that I could time it correctly. Let's turn the power on. Hello, hello. So this is 31 volts in and about 300 milliamps. And what we have is a circuit limiting coil spread. It's a motor generator. Pulse motor generator. And we're just about ready to see illumination on our light over here. It's going to light up. See, it's lighting up. Yeah. Woo! Thank you. Yeah, it's quite a bit of fun. After you get over the basic hurdles of making a good rotor, this is all fun. You want to make sure your magnets don't go flying everywhere. That means you got a good rotor. As long as it can spin, you know. You tweak it up, you know, get ceramic bearings, full ceramics. Our hybrid ceramics is good too, as long as it moves smoothly. Yeah, it's definitely a DC brushless motor. It's let me explain how the power goes in here and why both switches are definitely being utilized or have to be utilized in order for this to work. So you go from the power to this wire right here, and from that wire it splits into two circuits. Okay, so it goes into two coils from this point. This white coil and the brown coil over there. Alright, and hello, hello. Yeah, there's quite a few connections. And I don't solder, so what other options do I have? I'm using these clips as well. They're linking, because both of these coils here are Trifilar Coils, and that's why they're current limiting coils. Because it goes, this one goes 18 to 20 to 32 with a diode in between each one. And the other one goes 20, 24 to 32. So both of them are limited to 32 gauge in regards to the resistance. But the weight here is different than the normal 32 gauge coil of the same length. It's a lot less wire, kinda. A lot less length with more mass. Alright, okay, so that's basically the bonus you get for doing one of these coils, is you get more mass with less turns. And it's all limited to the same 32 gauge wire. That's awesome. I'm using this reed switch right here, and both of these coils are hooked to one end of that switch, and then the other end of that switch is hooked to this transistor right here, the collector of the transistor, and then this coil is hooked to the base of the transistor. So you need both of these switches in order for it to fire. Hello, hello. I don't understand. Anyway, this is 31 volts in, about 300 milliamps. So that is a little, that's about 1,150 RPMs. And that's going to be about the max we're going to get. You know, if I get my buck converter, I'll be able to do 60 volts. I had an amplifier, but it burnt out. So 31's the highest I can go. Never stopped. It's all right though. I got issues, so it's okay for me. Not anybody else though. All you gotta grow up, man. That's it. Okay, enough joking around. Let's see here. This is the other thing I got going. Now, if you look to the side here, these magnets are freaking huge on the side of this thing. They're 600-pound neodymium N54 magnets. Okay? Very powerful. No, this isn't a motor. There's no electricity on this side of the room. I'm just going to spin it with my hand. Alright, and boom. Yeah, the amount of friction on this rotor is virtually nothing. You get air friction, and that's about it. That is all the friction you get. Just that pole spinning on that magnet. Awesome. No, I can't tell you that. I spinned it with my hands. And I can tell you that much. And it's being held in position, I do believe, by the weight and the magnets, because they're set up to repel. But no, motion begets motion, my friend. You can't do it like that. Now, what you can do is you can put some momentum into it, and then those magnets can either prolong the momentum or they can slow the rotor down. And you try to position them so that it kind of moves right through the magnet as best it can, instead of, you know, being having friction at that point. You know, Howard Johnson, a bunch of other people have been trying to do, trying to do that for a long time now. And that setup over there is not optimized, but it's pretty cool. I'm going to go over there in a few minutes and we're going to see if it's still spinning. Don't worry about people that think this stuff is magical, man. It's pretty scientific. Yeah, there's no infinite energy. Well, the only infinite energy, I would say, is not AC and DC. It's not AC or DC. It's not solar. It's not any of that. That's not infinite energy. You would think that the sun and the solar, that's infinite, but it's not at all what I'm talking about. I don't know if we have a true tap into infinite energy yet. There's an anti-entropy circuit going on out there. I think that is dope. That's really cool. The anti-entropy circuit is like the first step to tapping into that energy. And that takes the energy from around the immediate area, all the heat, and it pulls it into the circuit, transferring it back into energy. I don't know too much about it, but you know, Old Man Builds, got to give a shout out. He was working on this a great deal. He knows a lot about it. I don't know what you're talking about, man. Let's find out. Yeah, they're a little warm. They're not hot though. It might be even room temperature, like just about room temperature. Let's try this one. No, that one's still good. See, I think the energy being released from the switch over here, like we get a little small arc. And I think that's keeping everything cool. And this one's just a trigger, so it's not, definitely not hot. Very little warmth. I thought they'd be warmer than that. So definitely not hot, but they are getting noticeably increased in temperature. But that thing is still spinning with the magnetic interference. I mean, if the magnets are causing an issue, this thing is still going. Sweet. It is, you know, that high off the ground. It does not start in the stop position. I could make it so it starts in the stop position. All I gotta do is move my switch around a little bit, and then just have it be in a closed position when I turn the motor on, and it'll start. But as for torque, this motor does not have a lot of torque. What's up, Jack Black? Nope, sorry. I wish. Hello, hello. I guess you could call it that. I guess that's what people are calling it these days. When you put 31 volts in, about 300 milliamps, so that's, what is that, 90 watts? Something like that? Or is it 9 watts? Anyway, you put some watts in, you get some, you know, kinetic energy, you get the light bulb energy coming out the other side. So that's basically a motor generator right there. But it isn't free. Good God, man, that's going to cost me money. Now, if I was running it on batteries, I'd still cost me money. It cost me $1,000 to get the batteries I need for this thing. Haha. Money. Money is always an issue. Money is no joke. The root of all evil is the lack of money. Okay? Slowed down? Yeah, I don't hook up, you know, circuitry to stall my motor, so I don't know what you mean. I can turn it off. And it will slow down, but it'll slow down at a medium pace, not a stall out pace. None of that circuitry is hooked up, so I can't do it. Alright, so since we got some new people showed up, I'm going to explain it from the start. This is a pulse motor. It's being run by this power supply, and the power supply feeds this trifilar coil and this trifilar coil simultaneously. Those coils dump into this switch, which has one connection to the transistor at the collector, and then the emitter is grounded to the power supply. And then we have this coil right here, which is a trigger, and it's hooked to the base of the transistor. So in order for the motor to run, you gotta hit this switch, and that'll send the energy to the, it'll send the energy through to the transistor. And then you gotta hit this one at the same time, basically, and it'll open up the base and send it through to the emitter, grounding the circuit. Thumbs up. This coil is a trifilar at 18, 20, and 32 gauge. So it's current limited to 22 gauge, or 32 gauge, sorry. And they're all connected with diodes. Some are bigger than others, but all of them are fast switching. And that's limited to that. But this is the benefit of having this. You get minimal amount of turns with the same amount of, so you don't have all that mass, but you get your current limited. And that's not what I mean. You do have all the mass. It's hard to explain. You get all that mass with fewer turns, so less length is what I'm trying to get at. So it actually adds up to a lot more power initially, and build up quickly because of how short the coils are. It's a MPN, just your standard MPN audio transistor. But yeah, if you hook it up with a better one, you're going to get better results. I believe it's I don't know if you can read that. That's it. They're rubbing off, man. I can't get a good one anymore. But either get one of those, or there's like this M.J.L. Those are good. Those are really good. They're better than these ones. Where was I? Yes, indeed. So what you're telling me is I can reduce the cost even more if I find a way to put those sparks into use, right? There's very little inductance in these coils. I just got done basically kind of alluding to that. There's a lot fewer turns in these coils than there would be in, say, 32 gauge coil of the same size. Would be so much more inductance than one of those coils. But this one's got the 18, the 20, and the 32. So I'm saying it's minimal inductance, and we actually have, this is how much energy is coming out of this cap bank. And the cap bank is hooked to the end of the 32 gauge and the beginning of the 18 gauge. So all that circuit's energy, AC, is being dumped into this cap bank, and this is what we're getting out of there. Minus, grant you, what it takes to light that light bulb in the back. Uh, Sometimes it can definitely be. It depends. It depends. I change it up so much. I haven't found something that I really, really liked. You know, I'm just feeling around still. I've been doing this for 3 years and I'm still feeling around. Um, no, sir. I don't know about that. The voltage is stopped and the current seems to be fluctuating quite a bit. But once you get to the point where you turn this on, then that voltage stops rising, like basically completely. You might get up to like 78 volts. Now here, watch this. I'm going to turn the light off. That'll cancel the load on the system, okay? And we'll see what happens. Yeah, I don't want my caps to pop, but wow. Woo! We're going up. But yeah, it's definitely the light. Now watch this. See that? Pow. I'm just lighting light bulbs right now. That's all I really ever do is light bulbs and get the kinetic energy flowing. This is actually it's kind of a unique circuit. I know one other person that does it like this with the contact switch and the trigger switch simultaneously. So the power goes in from the power supply into this coil and this coil simultaneously. Then those two coils dump into this switch, and then the red line hooks that switch to the transistor, and then that transistor is grounded to the power supply. So you can see how right there, and then in order to make it all work, we have the trigger coil that will trigger the base on the transistor. So it's not really a double whammy, but it's cost effective because running this switch reduces the cost by a lot. Like the cost over here, the initial cost. It's amazing. Now it doesn't go this fast, but I've gotten it to where it's been like 50 milliamps. But what you do is you reposition the switch, the commutator switch or the contact switch over here, to hit at a different frequency. Same position, you just bend the metal a little bit, and it'll hit at a different frequency. Thank you. Good night. All right. Oh, our wheel did stop, finally. Awesome. Welcome, ladies and gentlemen. It's Papa Bale. Welcome to the channel. And we're looking, this is a 4-magnet rotor, by the way. So, like every magnet is in play with the coils on the outside. So, and the switch. Now, this circuit will run with just the switch, but it won't run with just a trigger, but it will run with both. So cool. Now here, I'm going to change this up a little bit. I'm going to knock the 32 gauge strands out of the equation with just by clipping this thing in a different position. Alright, so here I'll show you how to do this. You take the clip off the 32 gauge and you clip it to the end of the 20 gauge. right? And then this one, unclip it from the 32 and clip it to the 24. Hey Yanni, what's up? Yo, yo, Mike! God dang, dude, you have put me in a state of heck yeah, man. The switch, dude, inspired by you. Or, yeah. And they're all in a half-inch away. Oh, shit. Excuse me. I had that on 31 volts at no resistance. Whew. All right, here we go. You saw that arc, didn't you? Wow, I was like, uh-oh. Now I've unleashed the current, basically. I've changed it from a 32 limited to a 20 over here and a 24 over there. So now we're letting loose a lot more current. You can see by the arc on the switch, it's getting bright. Got a bug in here. Whew. All right, so about 1100 RPMs with both switches on. Oh wow, wow. See that? I'm gonna turn it down and maybe current it, limit it back up again. That's way too much. That's like fire right there. that was nice. I just, gonna put these back. Put them back. Just gonna back it up. Yeah, we're gonna back it up. Back it up. Damn. Let's leave the other one at 24 and see what happens. Oh yeah, yeah, that's way better. Yeah, 24 is a mighty, mighty. Yeah, I want to, like, what do you call it? Um, Harness that some way. There's a way to get that in capacitors, just by hooking them up to the line, and you get less of an arc. But I need to get all those out of my storage. But yes, at least that's what me and Hall Effect came up with a while back. Now this is it, man. This is 32 restricted. This is both 32 gauges hooked up, and I think we're gonna get a lot less speed, but that's just because we can only put 31 volts in at this time. This is a circuit designed for voltage. We're going in the right direction now. So the current limiting reduces that current draw by, like 500 milliamps. And then when I readjust the commutator switch, contact switch, I can get it to double bound. Like, I can get it down to 50 milliamps. It doesn't go this fast though. And it's weird. It's like, it's because not every single hit causes an arc. It's basically, I would call it cheating, kind of. I got the fire department on speed dial. Oh yeah. Oh yeah, I can hear it revving up. We're almost to 1,000. So like, when I'm limited to 32 and it starts from a slow pace, I'd say definitely that those 10 minutes are a necessity. So thank you for that information. I was always like getting illegitimate readings. About 5 more minutes. We're almost to 1,000. That's so cool. So we have the 18 gauge strand going through the 20, going through the 32, and the front of the 18 gauge and the end of the 32 are hooked up to this cap bank. The blue spark. I see what he's saying. But yeah, man, that's high current draw. The current draw, well, my current draw at 31 volts goes through the roof. But like, we're gonna leave that one limited now, and we're gonna move this one back to 20. Try and get some more of that greenish blue light. Here we go. So this is 20 gauge and 32 gauge. No. I said I was going to look at that. I never looked at it yet. Yeah, this is it. This is it. We're almost to 1100 now. So this is 20 limited and 32 limited. And it's 300 turns less length in this coil. 1100. Yeah, look at that light now. That's beautiful. Yeah. I've been, told that I need to look at the Searle device. Yeah, hell yeah, Yanni. You do that. That is awesome. Have you made a geometry yet? It's slowing down. Hell yeah. It's going to be really hard for me to do one because I shake, man. My tremor is bad. It's induced by medication, whatever. I got you. Yeah, those look tricky, man. And that's the other thing with the switch, building it like this, like I do. It's got its limitations. I tried 18 gauge this time, make it a little stiffer. Oh man, I just want to throw this out there. My first rodent coil was a 36-point star, and it was basically explained to me by Robert Murray Smith how to build a 12 and a 36 all in the same time. Listen to both those videos. Yeah, he taught me how to do just the two-dimensional ones. But yeah, man, that was fun. That was that was great. All right. So, oh yeah, we changed up the current, didn't we? Here, we're only at 20 volts right now. Let's turn it up a little bit. 25 volts. Oh, look at that. Wow, dude. That is brilliant. Hello, hello. You are looking at the arc on my commutator switch. And it's running my pulse motor along with the trigger coil. There's now 25 volts going in, 600 milliamps. Look at those sparks, man. Wow. That's from the current opening up. About 1,000 RPMs. Let me cut this back. Turn. So I think if you just let it run for a longer period of time with the 32 gauge limited, you're going to get the best results. Now, if you need it like sped up in a hurry, you want to open up your current a little bit. Yeah, I heard. You saw those? Yeah, those sparks are nasty. I think it's because of how quick I put together that tip there. That screw is definitely in contact with the copper, but I don't know. Something's not right. Yeah, way too much current. Yeah, I just had it opened up to 20, which is right there, that connection. About 700 milliamps for all that at 25 volts. But now it's running 31 volts at about 200 to 150 current. Oh, I heard you. Yeah, but I can't. I don't have any coils that'll do that. They're all like this. And I know I need 2 pounds of 24. I know, but I just don't have it. I don't have any 24, actually. I have 30, 26, 20, and 30. So what you do to limit your current just a little bit more, see, that's better. And it's hitting almost every time. You can see it's a little bit more SOS like now. Let's see if the RPMs took a huge hit. It's like they took a big hit. Yeah. Move it in a little bit. Yeah. So yeah, that's where I'm at, like right around 150. And I wouldn't say it's no good, because I mean, what are you trying to do with yours? I forget. I'd say it could be better. That's what I would say. Not much. The arc isn't on the wheel; it's on the switch, and it allows the electricity to flow from the coils to the transistor. The only 24 gauge I have is in this coil, really. And then I have maybe one more red one that's like, I might use that one. That's it. That might actually work, because it's one of the 1 pound spools, completely filled with 24. So I think that one might do it. 'Cause now that I got this switch made, it's a whole different ball game. I mean, I can use coils that I couldn't use before, because I was using the transistors and I needed some way to trigger that. And I guess I could use a switch, but I don't know. I use trigger coils with the whatchamacallits, transistors. And I'm dying to see what it'll be at 50 volts. Because these coils are short, really short, because of how they're made. It goes 18 gauge, 20 gauge, 32 gauge. But they're all the same length. They're all 300 turns. Okay? So you get what I'm saying? You get more mass for the limited amount of turns, but you get less length. It's under a load right now. And I guarantee that that light has got more resistance in it than any resistor I have currently. Yep, too late. It is resistive. The light definitely has resistance in it. Especially these ones down here. Awesome, man. Welcome. Welcome, welcome. And if I was to use my one resistor, which is a 200 ohm resistor, I would definitely put it on the base. Awesome. Alright, I'm going to check the heat. Wow, these coils are still like not even, barely even warm. It's amazing. Well, where would I do that? Where would you want me to put the super capacitor? And why would I need one? Let me break down the circuit and we'll go through it piece by piece and you can tell me where I should put it. Alright, so it starts here at the power supply. Then it branches off and it goes into this coil and this coil. Filters through both coils, going through several diodes directionally to the switch. They're both connected, the black and the yellow. Both coils are connected to the switch. The other half of the switch is connected to the transistor. I'm not going to touch it, Yanni. Nope. I think it's fine. It's functioning fine. So I'm not even worried about it. I would say that it's probably got a little bit of heat to it. But we'll just have to cross our fingers. All right. And then the base of the transistor is connected to this coil over here. And then that coil, triggers a transistor and it flows through back to the power supply. Look at that. Wow. We were below 100 for quite a while there. Now, if I can get an app for my phone that's free, that allows me to, view heat signature, I'll do that. And it's got to be real and free. It can't just be free. Because that's such a useful tool. I don't know why people charge money for that. Everybody should have one of those, heat-seeking things for their phone. Now, you really can't touch the transistor when it's on, or you ground it. And when you ground it, it works half as well as it does when you buy it. It doesn't ground. As far as I know, if you touch anything that's connected to the collector, you're gonna fry it. Like, you're gonna ground it instantaneously, and it will never work properly again. So it's just when it's on. Here, I'll turn it off. That's a really quick solution. Oh my God, it's cold. It's freaking cold. That's amazing. I wonder why or how I'm doing that. This is a standard heat setup, it's a hot setup. That's interesting. I wonder what part of this could be doing that. Maybe it's the rotor. Maybe it's the rotor itself. Seriously, I don't know how I did that. What part of this, how did that happen? Is it the rotor? Or is it the combination of the two switches? Okay, well, it's white now. The spark is white. I don't think it's doing what it's supposed to do. That's awesome. So it is the contactor switch. It's copper on copper that's doing it, right? Yeah, but I mean, the only reason I have a spark to begin with is because of the copper on copper connection and the electricity running through it. Like that. No, it doesn't have to be copper on copper. It can be just any old connection. Because my paper clips do it too. But I haven't been able to get anything but white with the paper clip. Alright, there, that's some blue. It's white still, but you get a little bit of... Okay. See, now it's losing its... I think I should, maybe use some pliers on that. It's getting loose. Like a little loose. I'm just seeing like which ways are giving me less milliamps on the meter over here. There we go. It's like 50 to 100 now. So I had to back everything off a little bit. I don't know if the RPMs are probably not where they were before though. Yeah, that's not good. Yes, mag left. Hell yeah, man. The But see, I don't know. There's a problem with me. I like can't have my learning on all the time for some reason. I can only learn under certain circumstances. Here we go. I'm gonna let that ride for just a second. Where? There they go. Let's try and tighten that up a little bit. There we go. It's just not flopping around anymore. Alright, I'm going to explain it for you. Hold on a second. Oh no. Let's see if I can do this. There we go. About 100, average of 100. Say what now? Alright, I'm going to explain this to you right now. Alright, this is the circuit. goes from the power supply. And then from the power supply it branches off on the positive note to these two coils, this one and 180. Then it goes from there and it goes down to this switch, commutator switch, contact switch. And then the other end of that switch is connected to the collector, the transistor. This coil is hooked up to the base of the transistor, and then the transistor's emitter is hooked up to the power supply. And that's pretty much it. We've got this light bulb. Let me explain how that's being, the energy for that is being produced. We've got this wire hooked up to the front of the 18 gauge strand, and we've got this wire hooked up to the end of the 32 gauge strand. So it goes 18 to 20 to 32. They're all connected in series with diode. So you hook that series coil up to the cap bank here, and the other end is hooked to the light bulb. You can draw yourself a picture. I'm not doing that right now. Please. Believe me, if I had one, I'd give it to you. But I gotta go. Thank you very much all for hanging out. I really appreciate it. Peace out. Have a wonderful night. Bye now.